Hi everyone, welcome to the Dynamic Maths channel. Today we will be answering some exam grade questions based on quadratic functions. If you are still unsure about quadratic functions or equations, I have linked two videos in the description box below. If you're ready, grab a pen and paper. Let's get down to business. Let's move on to the first question. Here, the straight line y equals 5x minus 3 does not intersect the curve y equals 2x squared minus x plus p. Find the range of the values of p. Here, let us draw the functions first. We have the straight line, which is a positive gradient line, and then we have a curve, which is a quadratic curve, which does not intersect. Here we can see that it does not intersect, and we have to equate the two equations together to find the values of p such that it does not intersect. Now we will solve x. After this, we need to understand that there are no intersection with the two lines, which means they do not share a root with each other. When there are no roots, we use the test b squared minus 4ac less than 0. We have the value of a, b, and c, and we substitute the values accordingly. Here, the value of p is more than 3 over 2. If it's more than this value, you are guaranteed to have no intersection between the two functions. We can see that by using two different functions with a quadratic curve and a linear function, we can use the test b squared minus 4ac to determine whether it has an intersection or not. In the next question, we have fx minus x squared plus mx minus 18 has a maximum point of b3q, which is over here, and intersects the fx axis at a. We have three sub-questions, and let's start with part A, which is state coordinates of a. In part A, the position of A is such that it intersects with the fx axis. If it intersects with the fx axis, that means the position of on the x-axis will be 0. Therefore, we have to solve this question. When you substitute 0 into the equation, you will have minus 18. But wait, we haven't solved the question yet. We had to get the coordinates of A. Therefore, the coordinates of A will be simply 0 and negative 18. There, this part of the question is a piece of cake. Let's move on to part B. we had to find m and q using the completed square method. We had to convert this equation into the completed square method. The completed square form is as follows. To obtain the maximum point, we need the x coordinate and the y coordinate. This is the value of the x coordinate and this is the value of the y coordinate. Now, if you refer to my previous video in the quadratic functions guide, we have found a relationship between P and Q with the general form of the equation. The formula is as given. P equals to Q equals to all you have to do is to substitute the values of A, B and C into the equation and we can get our values for X and Y. Now our coordinate for X is 3, which is equivalent to minus P. This is equivalent to m plus 2. And the value of m equals 6. We do the same thing to y. Y is equals to q. And q equals to minus 18 plus m squared divided by 4. When you substitute the value of m into this equation, the value of y will become negative 9. Therefore, m equals 6 and q equals negative 9. This is the answers for m and q. Let's move on to part 3. Here, we have to determine the range of values of x if fx is more than negative 13. Let's write down the equation fx. Because we solve for m and the value of m is positive 6. Now we need to find a value such that fx is more than negative 13. We substitute the equation here. And solve for x. If you solve for x, you'll notice that you will get this function. Now you can use the quadratic methods to solve for x. I use the factorization method and I'll get this equation instead. Now we equate this equation to 0. We will get So the range of values for x to be more than negative 13 would be 1 x 5. It has to be between 1 and negative 5. This is the answer for our question in part C. We have completed 2 questions based on quadratic functions. If you have any doubts, please comment in the comment section below so that I can help you clarify them. If you find this video beneficial, like and subscribe to this channel. And don't forget to share this video with your friends. This is the Dynamic Math channel signing off.